Good afternoon, guys. Welcome to another webinar series done by 99X. I am Isuru Vikramsinghe. I have been working in 99X for 2 years as an associate tech lead. Today, we are going to discuss about Azure infrastructure as code with Bicep. If you have any questions about the session, please put a comment in the comment section. If time permits, we can discuss those questions at the end of the session. So let's jump into today's agenda. First, we are going to discuss about what is infrastructure as code, then benefits of infrastructure as code, what are ARM templates, what is Bicep. Finally, we are going to show you how to create an ARM template using Bicep. So what is infrastructure as code? In short terms, we call IAC. Before going to the definition, let's think how infrastructure was managed traditionally. If I need resources like database, web application, or virtual machine, I log into management portal or administrative portal and point in and click into provision needed resources. If there is a system admin in our organization, I have to create a ticket and ask from him to provide needed resources. Actually, this was okay if I don't have to manage a lots of infrastructure. But nowadays in application, we have to manage a lots of infrastructure, and also we have to maintain multiple environments. So because of this manual infrastructure management, we have to face many problems such as maintainability, availability, and consistency. To overcome these problems, infrastructure as code came into the picture. Now let's go to the definition. IAC is the process of automating the infrastructure provisioning by defining the desired resource states and their mutual relationships in a definition file. It uses a descriptive coding language and versioning system that is similar to what is used for source code. IAC can automate the deployments of your infrastructure resources like virtual networks, virtual machines, web applications, and storage. Now let's see what are the benefits of infrastructure as code. The first significant advantage is we can have better audit trails. Like our application source code, changes to the IAC can be version controlled. So changes can be viewed in our Git tool. Then we can see who made the change and when the change was made. Another advantage is consistency. As human beings, we always do mistakes, right? So we can reduce these human errors using IAC. With IAC, we can transform the responsibility of resource creation to automated tools. So we can guarantee consistent deployments. Another advantage is better understanding of cloud infrastructure. When we use Azure portal to create resources, many of the processes are abstracted from the view. But if we use IAC to create resources, we can have a better understanding about how Azure works and how to troubleshoot. As an example, if we create a virtual machine using Azure portal, some of the creator resources like manage this and network interface cards are abstracted from the view. But if we create same virtual machine using IAC, we have a better controllability over all those resources. Another advantage is it's easy to manage multiple environments. Normally, when we develop an application, we maintain multiple environments. Most of the time, we maintain development, testing, and production environments. When we create these environments manually, I think you may also have experienced the production environment may be different from non-production environments. As a result of this, if we deploy a new feature to production, it will not work as we expected. So using IAC, we can reduce these kind of errors. Uh, with IAC, we can use the same configuration files for each environment, but supply different input parameters to create the uniqueness. Another advantage is we can have better access control. Using managed identities and service accounts, we can grant access to relevant parties, and we can make sure only those parties updating these resources. And having better access control, we can prevent incorrect configuration deployment to production. Now let's see what are the main approaches to infrastructure as code. There are two main approaches: imperative code and declarative code. In imperative code, we execute a sequence of commands in a specific order to reach an end configuration. In declarative code, we specify only the end configuration. We compare these two methods with examples so we can have a better understanding. In the left-hand side, you can see the imperative code approach to create a storage account. In the right-hand side, you can see declarative code approach to create the same storage account. In Azure, we can accomplish imperative code approach by using scripting languages like Bash or Azure PowerShell. In Azure, we can accomplish declarative code approach using templates like JSON ARM templates and Bicep. When we compare these two methods, I think you can immediately identify. In here, we have execute sequence of commands, and we have explicitly defined what are the commands here. But in declarative code approach, we haven't defined any commands. We only have defined the end configuration. So in imperative code approach, there are some advantages. When our infrastructure matures, it's difficult to maintain these script files. And over the time, these commands can be depreciated to updated. Now let's see what is Azure Resource Manager. When we talk about infrastructure as code with Azure, we should definitely talk about Azure Resource Manager. Azure Resource Manager is the service that enables us to create, update, delete Azure services. When you see this diagram, I think you can see Azure Resource Manager is like a middleware that is between user requests and Azure services. When a user sends a request to any of the tool like Azure Portal, Azure PowerShell, or Azure CLI, Azure Resource Manager authenticates that request and send that request to relevant Azure service. Now let's see what are ARM templates. ARM templates are configuration files that define the infrastructure and configuration in the application. ARM templates use the declarative code approach. That means ARM template describes each resource in the deployment, but it does not describe how to deploy the resources. There are two types of ARM templates, JSON and Bicep. Today we are going to focus on Bicep templates. So what is Bicep? Bicep is a domain-specific language that is specifically designed to create ARM templates. Bicep isn't meant to be used as a standard programming language for writing applications. In other words, Bicep is a transpiling language like TypeScript. When we write programs using TypeScript, finally those codes should be converted into JavaScript. Likewise, if we define infrastructure using Bicep, that template should be converted into JSON ARM template. Actually, this is automatically handled by inbuilt tools in Bicep. Now let's see what are the benefits of Bicep. We can have simpler syntax. It's easy to define variables and parameters in Bicep. We don't need to define complex functions. In the left-hand side, you can see Bicep representation for creating a storage account. In the right-hand side, you can see equivalent JSON ARM template implementation. I think you can immediately notice Bicep representation is more compact and more concise, and it is quite readable. But if we see the JSON ARM template representation, it is not quite readable, and you can see we have written so many code lines here. Another advantage is modules. Using Bicep, we can break down complex templates into smaller modules and reference them in a main template. So these modules provide easier management and reusability. Another advantage is automatic dependency management. When we create resources, one resource can be dependent on another resource. If we use JSON ARM templates, we have to explicitly define this dependency. But in Bicep, these dependencies are automatically identified. Another advantage is type validation and intelligence. Actually, I know all of you are programming experts, but can we write correct programs without better tooling? I think it's difficult, right? If we use Bicep, we can install the Bicep extension to Visual Studio Code, and after that, we can have better type validation and intelligence. Yeah. Actually, that's pretty much about some background about infrastructure as code. Now let's see how to create an ARM template using Bicep. Sajid, it's over to you.
Yeah, thank you, Isuru. So I will share my screen first. All right, so good afternoon, everyone. So I hope everyone gets some understanding about what is IAC, infrastructure as a code, and what is Bicep, and what are the benefits in Bicep over traditional JSON ARM templates. Now let's quickly jump into a quick demo, which I explained to you how to deploy your resource to Azure using Bicep. So in that case, I'm going to explain, like I'm going to deploy the basic app service plan together with the app service into Azure and explain what are the benefits and how to use these modules and everything. And before start writing your Bicep code, you have to set up your development environment that is capable to execute Bicep codes. For that, you need to install the Azure CLI latest version. So Azure CLI version 220 or later version you should need to install in your machine, and it will automatically install Bicep within it, or else you can install Bicep manually by executing these commands. You can just find these articles, simply go to you Google and search it. So it really easy to find. And again, I will share these links with you guys as well at the end. And other thing is like they have provided some extension to VS Code that is that will easy for you to work, or that will be easy to you to write Bicep code on VS Code. Like they have provided some intelligence and highlight some codes syntaxes as well. So these are the basic setup that you need to do before you start writing your Bicep codes. So let's quickly jump into writing some Bicep codes. So as I explained earlier, I'm going to deploy simple app service together with the app service plan. So I'm going to create a simple file called app plan, and the extension should be Bicep. So when soon after you create some Bicep file, after you installing this extension, I'll show it to you. This is the extension you should need to install. So if you have installed this extension on your VS Code, it will identify this file as a Bicep file, and it will suggest you some intelligence and all. So we have to write resource, and this is the how you mark down the resource in Azure, and you can give a name. So this is like a reference name throughout your script. So anywhere you can refer this code snippet using this app plan reference name. And after that, you have to specify what is the resource that you are going to deploy. So in Azure context, we are calling app service plan as server farms. And you can see here the intelligence are loading. So you can simply select one of them. And this one is the API version. I'm going to select the latest version here and block it this resource. So this is the app service plan code snippet. And here we should need to provide the location. So for the moment, I'm going to give the location as the resource group location, because I'm going to deploy this resource as a subscription level together with resource group. And the next one is the name. Name should be string one. So for the moment, I'm put that as a app plan. And the kind, so I'm going to create this app plan as a Linux one. So I'm put that as a Linux. And SKU. So this is the object one. And the SKU, it's like a basic app service plan. And the properties, I'm put this as a reserved true. And one thing I need to show you guys here, we have write some code snippet that can deploy app service plan into Azure, but these are hard coded values, as you can see, but we can integrate these values using a parameters as well. So you can simply create param and some name for that. So I'm going to uh, create some parameter that I can use as a prefix for entire my resources. So param and the parameter name and the type of the parameter. So I'm going to create this as a string parameter. And again, I'm going to get another parameter for SQ. So it's also should be a string one. And here you can see define your value as well. So I'm defining the value here as a basic SKU, and you can just use these parameters inside your code snippet like this. With you don't need to add something like word auto anything. You don't need to add those stuff. You can simply reference your parameters within your code snippet. And the another thing is this bicep codes snippets are capable to handle these interpolation as well. So here I'm going to use this name prefix to my app service plan name as well. So here you can see I'm using this interpolation as well. So here this code snippet will definitely deploy app service plan into a Azure, but most of you know if we need to deploy app service, we need this app service plan ID as an output. So here I'm going to specify an output here. Give it a name as app service plan ID and the type of the output parameter and what is the value of this output. So I'm referencing this code snippet as an app plan as I explained earlier. You can reference these values or this code snippet throughout your script using this reference name. So app plan and ID. So it's really simple. And one more thing I forgot to add is like I'm going to add some tags as well. So for that, I'm going to introduce some parameter as tags. So it's type of that parameter is object, and I'm going to use that parameter here as well. So when I inject in these modules throughout our main bicep file, I should need to inject these values uh, for these two parameters, because since I'm not specifying the default values for these two parameters. So our app service plan code is done. Now I'm going to create an app service. For that, create a different bicep file as app service. Again, you can start with a resource tag and give it a name. So I'm give it as an app service and type of this resource. So websites and the latest API version. Again, location. So I'm going to use the resource group location and name. Set it as app service. Again, we can use the same structure that we have used for the app service plan, like with the name prefix. So I'm going to use that. All right. And you have to specify the kind. What is the kind of this app service? So for now, I'm going to create a basic app service, and the app service plan ID. We should need to specify the app service plan ID whenever we need to deploy the app service. So it should define inside these properties. So properties is an object, and it has the parameter called server from ID. So we should need to get the app service plan ID from the app service plan code snippet. So I'm going to create a parameter for that. So it's a string one. I'm using that app plan ID. And finally, tags, because my Azure subscription has some rules that whenever I deployed some resources, it should need some tags. So I'm going to create the same parameter as I created earlier, tags. So here the this code snippet will definitely deploy the app service into Azure. Now we can create a main bicep file that will manage these everything like in dependencies as well. Like first create the app service plan, then get the app service plan ID from it and injecting that app service plan ID into app service and deploy app service, something like that. So I'm going to create a separate file called main.bicep. So this is the main Bicep file that we need to execute against a resource group or against subscription. So this will handle, or this will manage everything. So I'm stating this target scope as a subscription for now, because I'm going to execute this main Bicep file against a specific subscription, not against a specific resource group. But you can see, you can run these Bicep files against a tenant, against subscription, resource group, or management group. But for now, I'm going to use this as a subscription level. So for now, maybe you know that to deploy resources, we should need to have a resource group. So I'm going to create a resource group. So I name it as a resource group, and you can find the resource group and the API version, same structure, nothing difference. Here you can see the location. I should need to specify, but here you cannot use the resource group location because we are going to create a resource group. For that, you can use this deployment function and the location. So deployment function means this subscription level. So what is the location of the subscription will get as the location of the resource group. And the name, I put that as a RG. And again, I'm going to use the same procedure I have followed throughout this process. So I'm going to create the separate parameter called name prefix, and it should be a string one. And again, this time I'm going to assign some value, like for the moment I'm assigned this as a Bicep. And for interpolation, I use this name and the tags as well. So here I'm specifying the tags as well. So these are my tags. So I'm going to use those tags. So here, this is the code snippet that will create a resource group. If you compare the ARM template against this stuff, so definitely you can understand it's a huge code snippet is there in ARM template to create a resource group. But here in Bicep, you have to specify 3 required parameters to create the resource group. Now we have our resource group on our side, and then we are going to create our app service plan and the app service. So here they have some syntax called module, where we can invoke another Bicep file. So module, and you can search it, plan. You can give it a name like the reference name, as I mentioned earlier. It's available throughout this Bicep file. So I'm going to name it as a app plan module for a moment. And the what is the Bicep file that you are going to inject through using this module. So I'm going to inject, or I'm going to use this app plan Bicep file. All right, so what is the scope of this? So scope of this module is like a resource group. That means this module will execute under this resource group. So that means this app service plan will get, or will deploy it under this resource groups. So that is the scope. And give it a name as earlier, like for now I'm going to name it as a plan module. And the parameters, for the parameters, you can see they have this Bicep extension give some intelligence, like what are the parameters we should need to inject into this app plan Bicep file. I can, if I go to the again I plan Bicep file, here I have specified 3 parameters. First one is name prefix, second one is skew, and the third one is tags. So we should need to inject these parameters, not this one, because since this having some default value, but these 2 parameters I should need to inject. So I'm going to define those parameters. So I'm going to use this local parameter called name prefix as a name prefix variable into the plan module. And the next one, tags. So I'm going to use again this local parameter called tags as I inject into this bicep apply and bicep file, and I don't need to specify the SKU since it is having some default value. All right, so this will execute this apply and bicep code hereafter. And the another module that is we should need to execute is for the app service. So I'm going to name it as a app service module, and same procedure, no difference, and you should need to specify the scope. What is the scope? So and the name for this module. So app service module and the parameters. Here you can see this app service code module is required this app service plan ID, name prefix, tags. So I'm going to give it this name prefix local parameter and the tags using the local parameter and the app plan ID. Here you can see we have the app plan ID as an output parameter from our app service plan bicep code file. So using this module, we are going to execute this app service plan bicep file. And using this module, we can simply get these output values like this. So you should need to cross-reference by this naming for the module. So app plan module. So it will cross-reference for this module here, and dot, you can see the outputs. And if you can see the app plan ID, since we are defining the output app plan ID as an output in this code file. So app plan ID. So our app service is done. App service is now done. And another thing I'm going to show you in this session as well, right? Using this bicep binary file, we can simply convert the ARM templates into a bicep file and vice versa, like bicep into ARM templates as well. So I'm going to show you convert some ARM templates, which is created some storage account into a bicep file, and I'm going to deploy that storage account using this bicep file together with these resources as well. So I have a some ARM template code snippet that will deploy a storage account. So I simply into copy that ARM template into my workspace here. This is the ARM template, traditional ARM template, as we all know. So here you can see it has some parameters like name prefix tags as well. And here is the storage account deployment code snippet. Like it will deploy a storage account, and it's a standard one, v2 type storage account. It will use some tags as well. So what I'm going to do is like converting this traditional JSON ARM template into a bicep file. For that, you can execute some command in Visual Studio Terminal or Azure CLI as well, like AC bicep decompile -f means forcefully, and the location of your ARM template file. So here I have my ARM template storage.json. Using this, you can simply convert this ARM template into a bicep file. Okay, here you can see now we have this storage bicep file by generating by using our ARM template. Here you can see the name prefix parameters is there, text parameters is there, and the basic code snippet that will deploy a storage account. And the type is standard storage account, and the v2 type, and the tags also there. So here I'm going to remove this JSON template from here. Now we only have these bicep files. So now I'm going to invoke that as a module here in our main bicep file. So I'm going to give it name as a storage account, and the bicep file name, and same as previous, you should need to specify the scope. What is the scope of this? And give it some name. And the parameters. So name prefix, I'm using the same local parameter name, and the tags, I'm going to use these tags as well. So here we have entire main bicep file that will execute against a subscription. And first it will create a resource group within the specified subscription, and then it will try to execute these modules in an order. It will understand, or it will identify the dependencies among these modules automatically, so you don't need to specify the dependencies. But in somehow, if you have any errors within your modules or within your bicep file, you can simply specify the what depends on it. So here you can have some parameter called like depends on, so you can simply specify what are the resources this module depends on. And for this session, I'm not going to use that, because it will automatically identify the dependencies. So now I'm going to execute this main bicep file against a specific subscription. For that, you have to execute some code like AC deployment, and sub means this will execute against a specific subscription, and the type is like creating these resources, and minus f for the forcefully, as I mentioned earlier, and the your file name. So I'm going to use this main bicep, and minus L for location. So I'm going to deploy these resources in Southeast Asia. So AC deployment sub create minus F and your file name main.bicep and the location. So for now, it's going to be hosted in Southeast Asia. So I'm going to show you my portal first. So this is my portal. Here you can see I don't have any resources under this resource group, any resource group under this subscription. So what I'm going to do is like executing this command now. It will validate the bicep files. It's same procedure in num templates, or the as Isuru explained earlier, this will convert into a JSON file first, and then execute this JSON file against a subscription. So this will take a little bit of time. So I'll explain to you some other stuff regarding the bicep while this is executing. So here you can see this is a more readable one, as mentioned in presentation by Isuru. So this is very readable, very understandable by any person. But ARM templates has the more controllability. Yes, that is true. But when it comes with this understandable and readable manner, Bicep is more clear, more clean, more readable way to script at your resources. So that is the main benefit of this Bicep. And another thing is like this Bicep following the same procedure or same concept that is followed by Terraform as well. So if you guys have any experience with working with the Terraform, you can feel that as well. These are the same concept followed by the Terraform, but in Terraform they have maintained a different procedure. Like they have maintained a state config file or something to double check or cross check with the Azure live resources, what are the resources that I'm going to create, or what are the resources that will going to be updated, or what are the resources going to be deleted, something like that. But here in Bicep, we don't need to worry about this state file thing. This Azure Resource Manager will automatically check the actual live state from the Azure environment directly. So those burden is not there, because I have worked in Terraform as well, but I feel like it's a extra burden, but it has some benefits as well. Like it will decrease the mistakes that we can do, but it had some additional burden as well. But here we don't need to worry about this state and all. So simply we can write our Bicep code and simply execute this command. And as for the CI/CD, your DevOps pipeline, here you can see I have executed simple Azure CLI command. So for now, I think you can add some Azure CLI task or Azure PowerShell task into a YAML pipeline or into a traditional pipeline and execute this bicep file within your DevOps pipeline without any issue. But in future, maybe Microsoft will come as a default task or pre-configured default task for bicep execution like templates. But maybe as a developers, we can also create that kind of a wrapper around this Azure CLI task. But anyway, this thing is possible inside the DevOps pipeline as well. And final thing about this bicep, this is a open source project, so there is a GitHub repository. So if anyone is interested about this bicep, you can simply contribute those projects as well. So here I have my command is executed. So here it will show me what are the resources that is created and some additional details as well. So we can go to the portal and give it a refresh. Here you can see I have a resource group. So in my main bicep, you can see I create the resource group using this name prefix nrg. So I use this name prefix as a bicep. So my name for the resource group should be like bicep rg. Is you can see my resource group is there and the location is Southeast Asia. And this is the resource group. And if I go into this resource group, here you can see these three resources I have been defined in my bicep files have been created. So just double check with the code. So for the app service plan, I create the app service plan. The name should be like the bicep app plan, and there should be some tags as well. So if I go to the app plan, okay, just open these files. Oh, you can see the name as bicep app plans or the interpolation work also, and you can see the tags also is there. And the other stuff, for my app service, the name should be like bicep app service and the tags should be there, and that app should be integrated with the app service plan. So bicep app service is there, the tags is there, and then we can see that this app service is whether it integrated to this app service plan or not. So you can see the apps here. Here you can see inside our app service plan, our app service is there. So yes, that's all actually for the demo. So I hope you get some understanding. So this is a very quick demo. So I can't explain more complex thing within this demo, but I just need to give you some understanding how to use Bicep and what are the benefits of Bicep and how to execute these commands and all, and how to use this main Bicep and how to execute Bicep against a subscription, because most of the time these Bicep files are executed against a specific resource group. But in sometimes you need to create a resource group inside your script as well. So in that case, you have to maintain this target scope as a subscription and create a resource group. But if you need to execute this bicep file against a specific resource group, you can simply mark this as a resource group and oh, resource group and execute the other code snippet, other bicep files against it. So that's all actually for the demo. Maybe if you have any question, please put as a comment, so then we can discuss about this within a short period of time.
Thank you, Sachit.
Yes.
Yeah. Guys, if you have any questions, please put them in the comment section. We definitely reply them. And thank you guys for joining for today's session. If you like to see these kind of sessions, please subscribe our 99x channel and click the bell icon to get notifications.
Okay, seems like there is no questions. So I think we can conclude this session. Thank you very much, guys, for joining this session, and hope to see you in another session soon. Thank you very much.